Hello everyone, my name is Sigit Jayanto, Master of Information Technology student from Universitas Gadjah Mada. This video is present about my final project, cloud computing courses, focusing about the design and implementation of serverless microservices based on multi-tier web application on AWS for cost-efficient customer engagement. This project is built around a real world inspired by the case study, and it is demonstrated about how the project can apply about the distributed cloud services, microservices, and perform a cost analysis in line with the learning outcome number 4.
Welcome to my projects. So my project is related about the business context about Belly Brew Co. It's about a functional wellness food brand specializing about the good friendly beverage. To increase digital engagement, the company is offering about a free fermentation recipe ebook in exchange for the newsletter sign up. For this scenario, there is 3 main challenges that emerging about the first one is about the how to capture subscriber data securely, and number 2 is about how to deliver the ebook only in the verified sign up, and the last one is how to minimize about the operational overhead and costs, since the marketing workload is event-driven and highly variable. These challenges make the Belly Brew Co an ideal candidate for a serverless pay-per-use architecture that can scale automatically without server maintenance. To meet the requirement and design about the fully serverless multi-tier architecture deployed by the AWS Academy Sandbox by using the time of the US is1 or the North Virginia. And then this one is about the architecture diagram. This architecture uses some of the following AWS management services that I'm using about the Amazon S3 for the static website hosting, and then I'm using about the CloudFront. It is from the content optimization, and I'm using about the API gateway is about the front door entry point, and I'm using about the AWS Lambda is to computing about the layer for all the business logic, and the DynamoDB it is for the NoSQL subscriber data storage, and about the SES it is for the sending to ebook via transaction email, and also I'm using the AIM roles. It is to enforce about the privileged access. Because all components are fully managed, so there is no server, no patching, and no capacity planning. The system will run only when requests occur and supporting both of the cost efficiency and operational simplicity. During the testing in the AWS Academy Sandbox, the end-to-end workflow executes successful. That we know about that S3 static set display about the subscription from the correctly, and API gateway wrote about the request to Lambda as a designer, and the DynamoDB store a new subscriber record, and the content access services generated on the valid pre-signed URL that we can access, and the SES delivered the email to my textbook, and yeah, we can access the receipt book that is emphasizing about the Lambda execution. Then, to ensure about the modularity, it comprises about the 4 independent Lambda microservices that is responsibility for a specific business function. The first one is about the auth and validation services that I'm validated about the name and email field, and also apply about the input certification and reject about the malware request early. And number 2 is about the user profile services that store about the subscriber data in the DynamoDB and ensure about no duplicate email entries and record about the timestamp and subscription lifestyle. And then number 3 is about the content access services that I'm generating about the link permitted about the S3 free signed URL, ensure that the recipe ebook is never publicly exposed, and enforce about the security temporary download access. And the last one is about the notification services that I send personalized transaction email by SES and embed the pre-signed URL in the email and manage delivery feedback. These microservices communicate through event-driven Lambda invocation orchestrated by the AWS services. After the workflow demo, so this section is comparing and evaluate about the effective of the architecture that I can compare about the serverless deployment with a minimal easy to and ready as setup, by the cost modeling covers to marketing scenario that I'm using about this two scenario. That the first one is about the 10,000 by monthly, and then the 100,000 by monthly saying up. So by the serverless cost, that the scenario A is pay per use is by the $1.20, and by the scenario B about the scale linearly, it is up to 11 till $12, and this is by the server based cost that it is always on. Yeah, it's the different. It is by the scenario A, by the monthly, it is up to 30,333 US dollar, and yeah, to the scenario B with the same overhead is for the 30 and 32 US dollars. So I can conclude that the most serverless costs come from the SES email, while Lambda, API Gateway, and DynamoDB, and also about the S3 is remain about the extremely low cost. So this analysis show that the serverless is the highly cost efficient for the variable workload because the compute is built only when invoked. We can know about the cost comparison that I am already visualized by the bar chart that we know about the serverless is more low cost rather than about the server base. After implementing this project, this project is aligned directly with the learning outcome number 4, that the students are able to apply about the concept and distribute about the cloud services and microservices architecture that consider performance and cost. So the achievement evident that including about the distributed cloud design that I'm already design about the architecture incorporate with the multiple AWS management services, and also I'm already implemented about the microservices implemented and already know about the cost evaluated and also doing the working demo before. In summary, this project successfully delivered about the secure, scalable, and also about the cost efficient for the customer engagement platform from the Belly Brew Co, and the serverless microservices architectures can ensure that the reliable data capture, control, access to digital content, and also about the zero server maintenance, automatic scaling, and the last one is about the significant cost saving.
Through this experience, I strengthened my understanding about the cloud-native design and serverless orchestration and microservices decomposition, and I'm gained about the practical experience about the evaluating architecture choices that can make impact about the performance and cost in the distributed system. Thank you for watching my final project presentation, and I appreciate for your time. I'm looking forward for your feedback. Thank you.